Well, hello everybody and welcome to another video from the Canal Sidings Model Railway channel. This hopefully isn't going to be very long. I'll try not to waffle on, because although I have been working away hard on the railway, there's very little to show. And the reason that there's very little to show is that I am planning all of the wiring for the railway. Which I've really got to install most of before I can actually fit the baseboards together and start planning how I'm going to wire the baseboards up, because the baseboards will simply be plugged into a backplane, sorry, not a backplane at all, a back loom of wires, and that will use either 9, 15 or 25 way what you might call RS232 connectors. They're known as the DB range. So I'll be using DB9s, DB15s and DB25s. One of the things that I have actually done is I needed to mount the braking relay boards, which I have shown you before. I'll show you again in a minute. And I found these, which are just black boxes that you can fit together and screw together if you wish. I bought them from China. They took ages to come, but that's alright because I ordered them months ago when I knew what size I wanted. But they're only about £2 each, which I thought was brilliant. I bought 5 of them for a tenner. I think it was under a tenner. And what I'm doing with them, I'm not using them as a box, but I'm using them as a tray, and in that tray I am mounting my braking relay switching boards. So each box, each tray has got the ability to switch 3 braking sections, which is quite convenient because the braking sections are spread around the layout in 3s. One for the up main, one for the down main, one for the relief, and they're all side by side. So the feeds to them are very close together, so this worked the best way, and as you can see 3 of my boards fit nicely into this box. And what I shall do is this box will be fitted up not under the baseboard but underneath the shelf that holds this baseboard up, and it will be fitted up at this point. The looms, the back planes for the DCC will go in the top, and out from the middles will come the braking, will become the DCC section drivers, which will either be switched to braking or normal, and in the bottom go the outputs from the signals that control the braking. So if this was the up main, that'll just have one signal connected to it, which will be the signal at the end of its braking section. If this is the down main, that'll have one signal connected to it, which will be the signal at the end of its braking section. And if this is the relief, then there will be 2 signals connected to this, and those 2 signals will have to be connected via 2 diodes. So this will, there'll be an OR function going in. Either one can control the relay. Now the reason for that is that the relief line is bidirectional, and I have now worked out exactly how I'm going to do the software for that relief line. It will be the same software that I've got for all my other signals. You will just, at startup, after you've loaded it, you will program it as a bidirectional line, and the 2 signals in the Arduino will be then paired to be one up and one down direction, next to one another on, or close to one another on the relief line. And depending upon whether you're up or down, the one against the direction of travel will be permanently red, and the one that is controlling the direction of travel will be able to operate and will be the one that actually controls the braking section from its own braking sensor, which is in a slightly different place, of course, because they're on opposite sides of the signals. That's a complication, but it just means a slightly longer wire. If it's a bit noisy in here, by the way, I forgot to mention I've got a couple of fans going because it is very hot this Friday morning. So that's something I've done, and I've got the other boards ready to mount. So I've sort of worked all that out. The other thing that I've been doing, the other major thing I've been doing, which has taken most of my time, and I actually can't show you any of it because it's really difficult, is that using the program that I've mentioned before on this channel called Inkscape, I have, which is a freebie program by the way, as I've also mentioned before, and I have been drawing out a point-to-point wiring diagram, which, believe me, is complicated. And I'm glad I decided to do it that way, even though I've now been working on it for probably 5 weeks on and off. I get so fed up with it I have to have a day's rest and then go back to it another day. But that is on my laptop. But because Inkscape runs on anything, my laptop runs Linux. But because that's my work laptop. because Inkscape will run on anything, I can load the same file into a laptop sitting on my technology bench, which is behind us where you're looking, and from that I can load it onto a big screen so that I can actually see what I'm doing from within here, but I can also print out pages from it. I have a page here which is the subject of the next bit. This is a small part of that diagram. This is printed quite large because I needed to wire up something. And what you see here is the box, which I call the power distribution box. And that's the next thing I'm going to go into, and the last thing. So, what you see up there, and I'll just zoom you in temporarily, try not to do it too fast. What you see there is my power box. That's this black box here. This cable is the only way I can feed it at the moment. It won't be there generally, but that's what gets the power to everything at the moment. And into this box goes, as you can see, as you saw from my diagram. I'm not going to show you the diagram as I do it, but into this box goes the output of my SB5, which is hanging underneath the bench now, on the bench work, not on the race boards. That's my NCE SB5, which has always been what powers the Inglethwaite Railway. Just a 5 amp command station, and into it I can plug my power cab, and it doesn't use the power of the power cab, it uses its own power. That uses the power cab purely as a way of user input. So you can unplug the power cab and plug it in somewhere else, and the system continues to run the trains while the power cab's not connected. I've mentioned all this before a long time ago, but probably nobody remembers it. Anyway, this is my power distribution box. It's hardly a box. It's got a rear panel and a front panel, and these screws here, 4 of them, there's one missing there, just hold the front panel onto the rear panel via some hexagonal spacers, 50mm long. Unfortunately I only had M3s and I want M4s, so I'm waiting for the M4 spacers to come, which is why this front sags a bit, because I made the holes for M4s, but nothing sits right, which is typical. You only got M3s and I wanted M4s, but there you go, I've ordered them now. And what this box does is it splits the output from the command station into 6 districts, and it also contains the braking command station, which is housed behind here. There is an LED and there is an LED, and I'll probably power that up in a minute. I haven't actually got the power for it at the moment, but actually I can't power that up because I haven't got enough power points. Okay, so but behind here is the sprog, and there are 2 LEDs here which tell you exactly what the status of that command station are. So you can instantly look at it and see if it is still working as a braking command station, or if it's given up because you've shorted it out or something. Okay, power districts. What that box does is it splits, as I say, the SB5's output into 6 power districts, and each one of those has a very rudimentary current limit in it, consisting of one of these. Nothing more than a 21 watt 12 volt automotive bulb, the thing that cars once upon a time universally had in their brake lights or their indicators. Nowadays it's all going LED, so they're coming harder to get, but they're still available. They can be very expensive or they can be very cost effective. These, I bought a box of 10, which I think cost me about £3. I'm not sure, it might have been £5, but I was being offered 2 for £2.50, which I thought, I want 8 of them, is too much. So what I've got, the power districts are the up main, the down main and the relief, all separately controlled by a bulb, separately current limited by a bulb. Then we have the yard, which is what is on the new big baseboard that is made of foam, as you saw, which will consist of the locomotive stabling point and the engineer's yard. The next one is storage, which is everything that's in the garage. And the last power district actually doesn't connect to the railway at all. It actually connects to all the accessories that need to know that are controlled via DCC, and that actually goes to all my point controllers, for instance, whether they be the Merg ones, which I've got under a lot of my boards still, or whether they be our new servo controlled point motor using our CTA design. So that's the 6 power districts. The other 2 bulbs here are the 2 that you may have seen when I was playing, trying out things with the signalling, and they actually are one in each output wire from the braking command station, the SPROG. And you do need one in each wire in case you short it completely to an output from the SB5. It is possible for lots of current to flow under that circumstance, so we make sure that every possible direction it could flow in is protected, and that's why there are 2 for the braking. They will tend to glow if you put a lot of load on them. From about 700 milliamps of load onwards, those bulbs will glow a little, very, very gently. You won't see them unless you turn the lights down. But if you put a short across the section, then the bulb will limit the current to about 1.8 amps. You can't draw 1.8 amps because the bulb will light and drop too much volts, but at least they will control everything. At the moment I've got everything connected into that one bulb, that's all 3 lines, and we'll look at what happens, and we'll watch the bulb when I short everything out, etc. So that's mostly what this does. It is just a mass of wires all interconnecting and ultimately coming out here at the moment just on 2 wires here, this yellow and this orange. This is where the command station goes in at the moment, and it will be where all of the sections also come out. There is just enough space. That is a 15-way connector, I hope. Yeah, it's a 15-way, and that's just enough to do what I need to do to get signals in and out of that. What I have here is a power supply for something. Can't remember. Oh yes, that's the power for the SPROG. Forgot that. That's the power supply for the SPROG. This one that is connected here is the power supply for something else that's in here, which is a DCC current measurement. So all the current that's taken from the SB5, all through all of the 6 output districts, is measured on here. And the the maximum track voltage that you're able to get, I say that advisedly, is measured on here. Now it's measured at the input, so you can't get more track voltage than that, but you could have less if you've got voltage drop down your wires to wherever section you're talking about. And to that end, I've also built, and this is another little thing, I've also built this, which is a gash little box, which allows me to connect these two wires to the track, a couple of croc clips, connect those two to my multimeter set on DC volts, and I can measure average current from the DCC, or I can measure peak current. Now peak current should be the same as average current. It rarely is, because the fast edges of the switching waveforms produce spikes. They produce overshoots, and those overshoots provide effectively a higher voltage that you can measure than you've actually got. And apparently it's a rule of thumb. This seems a bit harsh to me. You know, it seems that it shouldn't be this high. But if the peak voltage exceeds more than twice the average voltage, then you have problems with your DCC distribution, and you will need to put some RC filters at the ends of some of your runs. We'll see what happens there. I've never been able to measure anything, but I built both peak and average measurements into there. This voltmeter on here simply measures average. And this switch here allows me to switch the current meter in and out, because the current meter does drop some volts, because it's simply a panel meter, a DC panel meter that can measure up to 10 amps with a bridge rectifier in front of it. Now it's not just a bog standard bridge rectifier, it's made up of 4 fast recovery Schottky diodes. They have to be fast recovery because of the speed of switching. And Schottky, because they generally are what you get for fast recovery diodes, but they are high speed diodes in other words, but they are lower on voltage drop than silicon diodes. So, than standard silicon diodes I should say. Schottky is a silicon doping method. But it still drops about 1 point something volts. So I can switch that drop out with this switch. If I pull that down, the current meter doesn't read, and the voltmeter goes up by whatever the current meter was sucking from it. So that's the only reason that's there, in case I get a problem, and I think it's because the voltage has gone too low. So what I'm going to do, as I say, my SB5 is on the baseboard down below. You can't see that from where I've got the camera, but what I'll do is I'll power that up and you can see what happens. Plug this in. You won't see the okay, there we go. So we're measuring the voltage. There's nothing running at the moment, so, but there are some locos sitting on the track. So we're taking about 80 milliamps, and the voltage, maximum track voltage, is 12.4 volts. Okay, what I'm going to do now, using my trusty power cab, I don't know if that's focusing, but it's not a power cab anymore, it's just a thingy. It's just a cab for you to be able to control locos. So I'm going to run something. Now I have had a little bit of a problem with derailments, so if I suddenly panic, it's because the train on the inner track has derailed, and because there's a rail come out of its fixing here in all what's been happening. Anyway, we'll run this one first. And I'm going to make it very noisy so you'll be able to see what happens. I've only got 2 sound locos on at the moment, but I'll put the sound on and run the locos. There'll be 3 of them. at a sensible speed. Okay, last one to start up. And you can see now, I'll get close to the camera, you can now see that we're drawing current. We're drawing between 500 and 600 milliamps, nearly just over half an amp peak, and the voltage has dropped a little. The voltage has dropped a little because more current you take, the more you lose across the ammeter. But also, this bulb is the only one that's working. If I feel that, I know it's warm. And excuse me, I'm getting dry. And if I was to short the track out, which I will do in a minute, you will see that everything stops and that bulb comes on brightly. But before that, I'll just sound a horn or two and watch the current. Pops up a bit. Let's try it in a different logo, see if it makes any difference. That loco's got a problem with its pickups, I'm going to sort that out. But as you can see, sorry it's really noisy, as you can see we have a means of measuring the current and the voltage, which is useful. What I'm going to do now is I'm going to kill everything. I'll just wait for this train here to pass me. And you'll see, I've shorted it out now, 1.5 amps is flowing, still effectively got 11 volts, but the bulb came on. Now, everything should start up again, which it is. We've lost the sound, but everything is now running again. It just recovers. It recovers because the command station didn't trip out. Only the box tripped it out. And as you can see, if I now zoom you out, there are trains running. They lost all their sound because that's what tends to happen. The sound goes away, but all the other information continues to go there. So I would have to go around and set all the sound up again. So we don't want short circuits, but when they occur, we can cope with them. But you see, the voltage from the command station didn't drop. It was still there. All that had happened, sorry, I thought we derailed. All that had happened was that the that particular power district, which is the only one I've got active at the moment, shorted out and the bulb came on. So instantly you can see which one has shorted out if this happens. So if you approach a point that's set wrong and you short it out with a loco, the bulb will come on. It's all got to be tested properly, but that was quite a long way from where the power is fed in, and it worked okay. So I'm going to leave you with that. That is, I say, as far as I've got. I've got to now continue to work on my point-to-point wiring diagram, and eventually rip all this out and start wiring it up, which means that there will be no trains running at all because there will be no track. It will get moved out of the way, and we'll be ready to wire up each baseboard as we go. So thanks for watching, and I'll see you next time, which may be a while because I don't really want to make a video when I've got nothing at all to show. So bye.